All right, well, let's move on to chapter 4 then. We're a third of the way done with the old stuff, I think. So I think if I'm not mistaken, I think all that stuff was on the first test. So now we're moving on to the stuff from the second test. So measurement and data analysis. Only a couple select things I ask you to know from this particular chapter. Difference between reliability and validity. So what were these two things? What's reliability?
I could mean that you get the same result over and over, but it doesn't mean it doesn't mean that it's actually true.
Right, yeah, reliability is repeatability. It means that if a scale is reliable or a measure is reliable, you can give it multiple times and get very similar results. Validity means if a scale is valid, it's measuring what it's supposed to measure. So if you have a, let's see, my brain's a little fried today, I'm having a hard time ad-libbing examples, I'm sorry. So let's say you have a scale that measures, that's supposed to measure sensation seeking, so how often people go out and look for exciting new things. Well, you could have a reliable scale that it's measuring something and it's doing it in a consistent manner, so people take it over and over and get similar results, but if that scale isn't valid, it means that whatever it's measuring isn't sensation seeking, but it's measuring something. So yeah, you'll just need to know the difference between those two. So for graphical display, you remember one of the big problems with graphs that we talked about was having a y-axis that doesn't represent the full range of values. That can, if those are extremely shortened in an extreme way, it can make very small differences look very big. So you'll need to know about that. Let's see, description. Oh yeah, and then there will be descriptions of studies. You'll have to identify the null hypothesis in that study, which, what's the null hypothesis in any study? Yeah, that there's no difference, that there's no significant effect. And then you'll need to know that difference between type 1 and type 2 errors. That's one that can be pretty confusing, so you want to make sure that you go over that and be familiar with some different examples. Remember, so does anybody remember what the difference was? What were type 1 and type 2 errors?
Type 1 is false alarm.
Okay, yeah, type 1 is a false alarm. You're saying something is there when it really isn't. You're saying you found an effect when the evidence doesn't actually support that. And what was type 2? What's that? Yeah, so you're on the right track. There's something there. There is a significant effect, but you fail to find it. And so that might happen because you just don't have a big enough sample, or the measures that you were using weren't precise enough. So there are a lot of reasons that can happen. And of course, both of those are bad. We talked about that. But you'll just mainly need to know, given the description of a study, what would it mean to commit a type 1, type 2 error for that study. And then we had these statistical concepts. I'm not going to ask you to know a ton about the different statistical techniques for this test, but you will need to have some idea of what statistical power is. So if you recall, power is your ability to find an effect, assuming that one exists. And that's going to depend on a couple of factors. One is your sample size. So larger samples usually give you more power. And let's see. And that's also going to depend on effect size. So effect size is exactly what it sounds like. How big is the effect that you're studying? So sometimes you can be studying something that has, let's say your independent variable has a significant effect on your dependent variable, but it's a really weak effect. And in that case, it's significant, but you're going to need a large sample if you hope to see anything. Okay? If you're studying something that has a phenomenon that has a large effect size, then you might see it in a sample of 4 people, see a significant difference. So you'll just need to know what those are. Any other questions about chapter 4? All right. On to Chapter 5. I think this is when we started getting into some of the stuff that people thought was a little bit more challenging. I mean, some of the stuff from Chapter 4 was tough, but this was our introduction to experimental research. So, designs that can allow you to actually determine cause and effect relationships. So there's going to be a big portion on the exam where I've got descriptions of experiments, and you just need to identify the different components of the experiment. And hopefully, by now, a lot of this is second nature to you. Identifying the independent and dependent variables. You all should, we've done that dozens of times in lab by now. And one thing that you might not remember as clearly is this difference between task, instructional, and situational independent variables, those different types of independent variables. So, does anybody want to refresh our memory on what the difference was between those? So what might help is if I just bring up the lecture, the slides in which we went over that, because I can't remember which examples I used, but I can guarantee you that this is going to be better than me trying to ad-lib something. Alright, where are we? Oh yeah, good old Mill's inductive logic. Necessary and sufficient conditions. Alright, here we go. So, yeah, we had the situational independent variables. And these were all examples of manipulated independent variables. Something, some characteristic that the experimenter changes. Right? And we contrasted these with those subject independent variables, like race and gender and so on. Right, so situational independent variable is some feature of the environment. Let me dim the lights here so you guys can see this a little bit better. And, oh yeah, I used an example from my own research there. The participants who perform a risky task in private versus when they think that someone is watching them, watching their performance. And let's see. Yeah, and we also manipulated their perceived relationships, the perceived relationship status of the observer. So for some people, we told them that the person watching their risky performance was single and interested in meeting someone, and in the other condition, we told them that this person was engaged to be married. So that's something that we manipulated. We told them these different things, so they were put into different types of situations, and we wanted to see how that situation would impact their performance. Right? Then task-independent variables, or just a difference in the task that participants perform. So I use the examples of the crossing out ease task, which I demonstrated on the slide there. Some participants perform a really easy task. This is on studies of ego depletion. So they just cross out every example of the letter E on a page. And other participants will perform a more difficult task that is really going to wear them out and deplete their cognitive resources. And so they would receive a more detailed set of instructions to cross out every letter E unless it's followed by a vowel and all these other conditions. Right? And so that's just a difference in the task that the participants are performing. And then finally, we had the instructional independent variables. All right, so everybody's performing the same task, same type of situation. It's just that they receive different types of instructions. So some people might be told that they're working toward earning $1 as their reward for completing this task. Other people might perform the same task but think that they're working toward trying to earn $10, and then they would rate their enjoyment of the task afterwards and think about their motives or something like that. All right. So anyway, the difference between those three types of independent variables. That'll be good to know. You all should be familiar with manipulated versus subject variables. I just talked about that. Lab versus field study. Either it's in the lab or it's out in the real world. Confounds, remember that's anything that you, let's see, I'm trying to remember the example we used, but we said that sometimes you might accidentally manipulate something that would influence your results. There was a really great example of that. Let me go back here again. Oh yeah, the distributed practice experiment, where you're having people study in different ways. And remember we said that there were some different confounds in this one. So our two confounds for this example, and this is people who are either studying in a way that's spread out or just studying once or twice. So one of the confounds was that you're also manipulating the total amount of time that people have spent studying, right? So you had these people study for 3, 6, and then 9 hours, but you didn't. That wasn't supposed to be one of your independent variables. You also have these people going for 4 days, or rather 3 days after studying, and then they take the exam. These people have 2 days that they have to remember that material, and these people just have 1. And so if you're studying the distribution of practice, you need to control for these other things. You would need to have everybody studying for the same amount of time and have the same amount of time pass before they take the test, but only manipulate how that practice is distributed. Right. So this is a rotten design right here. Right. So let's see. Then let's see. So y'all remember the Bobo doll study? That was that study of modeling aggressive behavior, where the little kids either watched an adult model who was beating up a Bobo doll or not. That one should be described in your textbook too. And then the field-dependent study. Remember, that was looking at that characteristic of field dependence, which determines whether you're the type of person that pays attention to the big picture or whether you're more detail-oriented. And you'll just need to review that one in your notes and in the textbook. Let's see what I asked about that one in here. Oh yeah, you'll just need to know what the different variables were in there, what was manipulated, what was measured, what was the independent, dependent, and so on. Right. So what were the different types of conclusions that you can or can't draw when using those different types of variables? What can you conclude if you manipulate your independent variable? Yeah, cause and effect relationship. You can't do that with the subject variable. Remember, if you are using a subject variable, that's correlational research. You're measuring things that already exist, but you didn't manipulate anything, so you can't say that you actually showed cause and effect. And what else do we have here?